you can just throw it in the basket. All right, guys, let's take a look. 5.5 and 5.6. We're actually going to take these two sections and combine them together. We're going to spend 2 days on it, today and tomorrow. Today, our learning targets are to find the number of solutions or zeros, which I've kind of taught this throughout everything this semester, so that'll take like all of 20 seconds to talk about that. And then we're going to talk about finding the zeros. Have we done that already? We found zeros, right? But every time we've done finding the zeros, I've always given you something. Today, I'm not giving you anything. You got to find all of them, okay? All right, so the first part is the technical name of something that we've actually been doing all semester long. It's called the fundamental theorem of algebra. Bottom line, it's how you figure out how many answers something has. So without even reading any of that, how many answers does this problem have? 3. How'd you know that? The highest exponent's 3. Look at that. You guys already knew this, right? Yeah. All right, moving on. All right, what does it mean when the graph looks like that? Ooh, very nice. Means we know it's a negative coefficient because it's pointing down. We knew it was an even exponent because of the shape it has. What do we know about one of the answers? Good. X equals 1 is one of your answers because it actually touched right here. How many times does 1 show up as an answer? 4. 4 or 6 or 8. Even number of times. You can go ahead. So when you're looking at your graph, and it's going to be really important today that we learn to recognize this, if your graph like bounces off of the number, it doesn't actually go all the way through, but just kind of touches it and comes back, it shows up an even number of times. Most likely it's probably twice, but it could be 4 times, 6 times, 8 times, 10 times, and so on. But how often have we looked at equations that are like x to the 10th? Not real often, no. We don't typically look at them, but it could happen. So if it actually like goes through, let's say this graph goes up and goes through somewhere, how many times does this answer count? Once or 3 times or 5 times. If it actually goes all the way through it, it's going to show up an odd number of times.
Wait, so like
Yeah, if it just kind of touches it and comes back, it's an even number of times.
so if it's an origin, then it's gonna be like line like it touches once.
Like this one?
Yeah, like that.
Right, if it just comes up, kind of like bounces off of it, it shows up like twice or 4 times. Okay, good. Yeah. Which chair is that? You guys in your crazy chairs. All right, so here we go, getting into the newer stuff for today. So we have a problem. Factoring some things is kind of difficult sometimes. Some of them are lengthy, takes a long time. And does everything factor? No. No, not everything factors. All right, like have we ever learned how to factor something with 5 terms? No, we've done 2 terms, 3 terms, 4 terms, but we've never touched 5 terms. So what we're going to look at is we can find one of the factors, or 2 of them, or 3 of them, and then use that to kind of break things down farther, okay? So in 5.4, we just kind of talked about this a little bit. Move my stuff out of the way. 1 factor was usually given. I asked you to finish factoring, right? That was your homework that you just turned in to me today. It's that same idea. Today, nothing's going to be given to you. Here's the problem. Find all the answers. I like this. This is one of my favorite sections. I know you guys might not like it as much as I do, but all right. You like a page like that, right? Big old X through it. There is a long, drawn-out, by-hand method for doing this, and I will show you briefly how that method works, just because I know there's some of you that like the why behind everything. I was that why student. But let's be honest, even me now, I can do it by hand. Do I do it by hand? No. Why would I? I have technology at my fingertips. Are you guys allowed to use graphing calculators? Yep. Why not use them to your advantage? Okay? So we'll go through, and I'll show you what it looks like. A couple of them, like the way I expect you to do them. Then I'll kind of go pick one of them. I'll show you the long method so that you can appreciate the graphing calculator a little bit more. All right, so here we go, step by step. So I'm going to find the rational zeros. Why does it say rational zeros? not imaginary, and not, she was right, not, they don't have radicals, right? So they'll be nice. Could they be fractions? Yes, they could be fractions. So find the rational zeros of that equation. So right off the bat, I'm looking at that. There are 5 terms. I don't know how to factor something with 5 terms. So let's grab our graphing calculators. Let's type it in. Don't forget to clear your memory first, right up here if you don't remember. All right, so what do we have for an equation, guys? X to the 4th. When you're typing in your X, hit that little caret button. Do you remember the caret? The caret's right underneath the clear button. If you look right there. All right, notice where my cursor is after I hit X to the 4th. You're going to have to hit the arrow button to kind of move it back over, because right now it's up in the exponent. You get some really funky looking graphs when you forget to pull that back down and you type everything else in. All right, so X to the 4th minus X cubed. Drop that cursor back down. Plus X squared minus 3X minus 6. All right, after we type it in, any issues or questions typing it in? Thank you, Alex. All right, then go ahead and hit graph. It looks awkward, doesn't it? Is that another stroke victim of a smile? All right, so do we have some nice, pretty answers? Do we know for sure exactly where they're crossing? What can we look at? Paige? Yeah. Up here in the equation they gave you? It's just the equation they gave you. Did you graph the wrong one? She graphed the next one on the paper. Yeah, good, Jacob. If we look at second graph, pull up your table. We call these things zeros, right? That's what we're always calling these things. So if we look at on your graph, -1, 0, and we have 2, 0. So we know for a fact that it did cross at a nice number. So we know 2 of our answers right now are -1 and 2. All right, so I'm going to come back to this. So we know X equals -1 and 2. Those are the nice ones. I can see it on my graph. I can double check on the table. I know they're the right ones. So how many answers does this problem have? It has 4, right? Because it's X to the 4th. I already have 2 of the answers. I'm not going to plug them in. Yes, we're going to use synthetic division. Okay. Yes, then yes. All right, do you remember synthetic, how to set it up? So we're going to have 1, -1, 1, -3, -6, and we're going to do synthetic, right? What are we going to divide by? Actually, not -2. 2. Yeah, they actually gave you the 0, so I don't have to switch the sign on it. So you want to use the 2? Okay. Yeah, we don't have to switch signs because they actually gave you the 0. And Bree said she wanted to do the 2. Does it matter if she does the 2 or the -1? It doesn't matter. All right, so if we do synthetic here, so we'll drop down the 1. Remember, we multiply, add, multiply, add, multiply, add, multiply, add. What should happen when you do synthetic division with these? What should you get every single time? A 0. Because if we would get a remainder there, that would mean it's not a factor. And we know it's an answer, so we should get a 0 there. All right now we started X to the 4th. I did synthetic, so what variable am I down to? I'm down to X to the... Good. Very nice. I'm down to X cubed. We're trying to get to a quadratic. So if I can get to quadratic, I can either factor it or, Jared, not favorite. I can use quadratic formula. Jared likes to factor everything. Oh, it's not funny if you weren't paying attention. Yeah, guys, we can do it again. If you want to write your variables in there, you can, but you know me, I'm that lazy mathematician. I don't want to.
Do we have to use the other one?
Yes. Now we use the 2. Now we have to use the -1. And we'll do synthetic again. So multiply, add, multiply, add, multiply, add. So we know 2 is a good answer. We know -1 is a good answer. Yes. We started x to the 4th. We did synthetic once, gave me x cubed. Synthetic again, gave me x squared. So x squared plus 0x plus 3 equals 0. Close. All right, so look, yeah, we have no x term, right? So if I have x squared plus 3 equals 0, how would we solve? Good, get x squared by itself. So x squared equals -3. There it is, square root. So x equals I radical 3, don't forget, plus or minus. Now we have 4 answers. Good. So we have 2, -1, and plus or minus I radical 3. Awesome. I'm glad you guys think this is easy. It's fun. I love this. No, they're really, if you were cool with this, you guys should be fine. They're really not too bad. All right.
Well, they always come up with pretty answers. Like if you mess up somewhere, well, like you feel like.
I think it's funny that you said pretty answers.
But I mean, like,
This is.
it's like pretty. You feel like mess up fractions. Is that like this thing?
Not necessarily.
Is there a way
We'll talk about some. Not a real direct route of checking, but I can look at the graph. Since my graph, hold on, I'm switching between too many things here. Since my graph, if I look back at this, I know it only crossed twice. So I knew right away that my other 2 answers had to be imaginary. So I can kind of check that part, but it's hard to check the I radical 3 because it's not actually on my graph anymore. Okay, so let's go ahead and take a look at the next one. Look how long that one is. Nice big numbers. What's your go-to? What's your graphing calculator? Yeah, let's type this thing in and see what we get. All right, so I'll graph it. You guys graph it. We'll see how we do. Honestly, it takes you longer to graph this thing than it does to actually solve it. Make sure you double check what you're typing in, because you hit one wrong button, your whole thing's going to be wrong. Oh, see? Yeah. That is called my touch board. That's not very accurate sometimes. Okay.
So weird.
Aren't they fun, though?
I don't like it. They're not pretty.
They're not pretty. They're not nice, beautiful, round, curvy lines. Did you fix it? Did you type it in wrong? Did you... Let him finish typing. Let's make sure he's okay there. All right, this problem, how many answers should I have? 4. It's x to the 4th. So 4 answers. Are you with me, Alex?
Yeah, I covered it up.
All right, so we have 4 answers. How many of them are real answers? Rational. 2, because how many times does it cross the x-axis? 2. So how many imaginary answers will you have? 2. Yeah. True or false? Imaginary answers come in pairs. Why?
Because it's positive or negative.
Good, they're always plus minus. Nice. Hi. What? What do you mean I can only find one on the table? What do I do? All right, let's take a look at what you're looking at. So he's looking at his table. And it looks like 1/3 ish. Yeah, kind of right in here on my graph. If I'm looking at my graph, it looks kind of like 1/3 ish. And this, your table only shows you integers. It only shows- Now this one, there is a way, and I'll show you here in a minute. So right here, it's looking at -2, and I can confirm -2 is a good one. So let's go back to this. Let's kind of talk about it a little bit. So you have some options. We know x equals -2, and the other one looks like roughly 1/3. Question mark, right? It looks like 1/3. I'm going to show you a couple different options here, okay? So let's go ahead and do synthetic with what we know is a good answer. So set up synthetic, 3, 17, 30, 12, -8. Don't forget to look for your missing pieces in there, in case you're missing like a cubed or a squared or an x or something. So we know that 2 works, right? -2? You guys are awesome. You're already halfway through your synthetic. Years of practice. Years of practice. All right, so if I do synthetic once, what am I at right now? X to the 3rd. I need to go at least one more time to make it x squared, right? Now, that 1/3 I'm not 100% sure of. Could I try it? What should I get for a remainder if it is good? I should get 0. Let's try. You know sometimes I lead you in the wrong direction on purpose, right? Alex, yeah.
That way we can get our answer.
Not really. Hang with me. I'm going to show you a couple different things here, okay? So it looked like roughly 1/3. Let's try. Let's see what happens, right? So 1/3 of 3, 1. Okay, you guys should know your math, right? 1/3 of 12. Question mark, thank you. 1/3 of 12, try again. All right, there you go, more confident. And it worked. It did work. All right, that makes you happy, right? But what if it didn't? Then what would you do? You don't know. All right. Guess and check. Let me show you. Let me show you on the graphing calculator. There is a way on here to figure it out, okay? So if you're looking at the graph, what I can do is I can get it to calculate exactly where that point is. Do you have a calculate menu up there somewhere? Remember, it has to be up here. All of these buttons deal with the graph. Good. Second trace brings up your calculating menu. And you have options. Which of those options do you think we want? 0. We're trying to find the zeros, right? So option 2. And you know your calculator always gives you those crazy left bound, right bound, all that craziness, right? So left bound, right bound here gets a little confusing because actually I want like below the line and above the line. So I can kind of, I want to know the 0, right? So I have to just tell it like above and below the x-axis. Now above and below is not always left and not always right because you got to look at from left to right. I read this thing, which direction it's going. So in this case, left bound, is it going to be above or below the x-axis? It's below. So right now my cursor, is it below? Second trace, and then choose 0.
Yes.
Can't you love it? So move it right bound. And then the stupidest feature on my calculator, do we want to guess? Why do you want to guess? Isn't that why I'm using the calculator? No, hit enter again. And 0.3 repeating is 1/3. Yeah, I don't know why it's even on there. It drives me crazy. I want to guess. I don't know. I haven't used that one in a long time. That's a really old one. All right, so there is an option that we can do it that way, right? So you can see 0.3 repeating is, we know that's 1/3. All right, that being said, this is a great opportunity for me to show you a little bit the by hand method. Let's finish this in its entirety, and then we'll go talk about that, okay? So we started x to the 4th. I did synthetic once, and now I'm down to x to the third. Synthetic again gets me down to x squared. So I have 3x squared plus 12x plus 12 equals 0. And we can try to factor this, right? Good, there's a GCF of 3. So x squared plus 4x plus 4. Will that factor further? Yeah, it does. So x plus 2, x plus 2 equals 0. So what's x equal? Negative 2, negative 2. Wait a minute. Didn't we already have negative 2? If it goes through that point on the graph, it shows up how many times? I got 2 of them here, and we already found one from the graph. So are there any imaginary answers? No. Uh-oh. We thought there was at first, right? Was that a little deceiving? Yeah, because negative 2 actually shows up 3 times. If we go back to that graph and look at that graph again, it went through at negative 2. That means that was an answer usually once, but could be 3, could be 5. We don't really know.
I still got an answer.
You should have still gotten negative 2 twice. Help him out, Anthony. Check that quadratic formula. Can he use quadratic formula instead of factoring? Yeah. As long as you're down to an x squared, you can use quadratic formula. Absolutely. All right, let's talk about the by hand way. I thought you were saying your ears because you don't want to hear it. All right, so by hand. Again, will I ask you to do it by hand? No, I won't. But it could possibly help you with the whole fraction part. If you're like, I don't really remember how we're supposed to use graph calculator, all that stuff to find it, there is another way. The way that I was originally taught, back before graphing calculators, because I'm that old, you would list your factors of, they call them P and Q. And it's your first number, your leading coefficient, and your constant term at the end. So what are your factors of 8? Wow, this shouldn't be hard. 1 and 8, 2 and 4. I took you back too far, basic stuff, didn't I? Your factors of 3? And what you would do is you would list all your possible answers, which means you would take your P value and divide it by your Q value. Just hang with me. So you'd have 1 over 1, 1 over 3. I would have 8 over 1, 8 over 3. 2 over 1, 2 over 3. 4 over 1, 4 over 3. Not only are all of those options, because I wasn't really sure, they're all plus minus. So what you would have to do if you didn't have the graphing calculator, hope you're a good guesser, and start trying them with synthetic and trying to get a 0 for a remainder.
But you didn't have to do synthetic, did you? You did like the...
I don't remember what I did back when I was in high school. I remember there are 16 possibilities. So could you do synthetic 16 times? But think about this problem. Negative 2 showed up 3 times. Would you have thought to maybe try it 3 times if you didn't see the graph?
No.
No. You probably would have tried all 16, right?
Yeah.
I probably would have. Do you like your graphing calculator a little more now?
I love
Yeah.
I love you. But for me, looking at that graph where it was actually 1/3, I can kind of think of this list in my head. Not necessarily the whole list, but is 1/3 even a possibility? I knew it was a possibility because of the factor here over 3. I knew 1/3 was a possibility. Whereas half, would half even remotely come into my mind? No, because I know that they have to be over 3 or over 1. So I wouldn't even try half.
So did you take...
when I taught at Finley, my advanced class there, I taught them by hand. They took a quiz by hand, and then I introduced the graphing calculator, and then they really hated me because I made it by hand first.
Before then, you didn't tell them it ever existed. Like,
I didn't. I taught them by hand, made them do it that way first.
then they're like, oh, then you could have done it this way. Like,
Yeah, then they hated me then. Yeah.
So you would take each number and put it over each number. There's like one over one and then one over three,
Yep.
8. Okay.
Yep. Going through all your factors. Yep, just pulling those over here. And then a plus minus goes with all of them, because, just in case. Yeah. So, do you want to use your graphing calculator or you want to do it by hand? Okay, yeah. All right. Please. Jared, did you figure out your quadratic formula back there?
yeah,
Okay.
he came out with 6. Yeah.
Oh, okay. I got you. All right. Well, as long as we're good. All right, should we try another one? With your calculator? I won't make you do it by hand, I swear. Although that would be a fun, like, bonus sometime. Just like... All right. Well, I don't know. Depends on the day. All right, so go ahead and grab your graphing calculator. Someone's a doozy. Let's type this thing in, see what we get. It's a doozy. Yeah, it's going to take you a little bit to graph this one. Some graphs are great. They weren't listening to me when I was talking. They were just typing.
I missed one.
Make sure you double check it before you even hit graph. Like double check that you didn't lose an X or something else in there. If it's missing like an X squared, then, I mean, the calculator can deal with it. You don't have to worry about the zeros when you're typing it in. Wow, mine is like thinking really slow. It's a positive chair. You guys in your chairs are weird.
I don't know. I
All
like
right, mine just like froze. How you guys coming? Did you find some answers?
No, I'm still typing.
You're still typing.
I screwed up.
All right. It's all right. I got to, like, mine just completely had a cow on that. Didn't like it. Minus 4x. Hey, Jared and Anthony, did you guys figure out where it's crossing? Did you find some nice answers? Or do you want to do it by hand? I know, you got distracted.
Why do I keep doing that?
-1 and 2. Oh, there it goes. What do you notice about -1? -1 shows up how many times? Even or odd? It's odd, right? Because at -1 it bounced off of it. So anybody not able to see the graph yet? Are you still typing it in, or is your computer or your calculator just thinking? Whoa, why do you have your hit zoom 6? You were like way zoomed in on that one axis and it looked really funky. Oh, hold on. Hit y equals. That's what I was just kind of wondering what you had going on there. I mean, that shouldn't make a difference. Scroll over because something's up. -4 plus. It's fine. Keep going. That's. Oh wait. Yes, take that off of there. Hit delete. And then hit a minus sign right now. Now hit graph. There we go. That looks better. -1 shows up how many times? Mr. Collins, if you want to hang out for a minute, we're going to do our brain break. We're going to do our brain break in a minute if you want to join us. Do you want to join us for a brain break? He has not been in here for any, but I did a meeting for the academic staff, and we did them. He likes it. He likes it.
So, it is not factorable.
All right, so we started x to the fifth, fourth, third, squared. All right, so x squared minus 4x plus 7 equals 0. That is not factorable. So, Jared, if it's not factorable, what do I do to solve?
What do you know?
Oh, Jared. There it is. It does not factor. So we can use a quadratic formula.
Wait, why doesn't it factor?
Options for 7 is just 1 and 7.
Oh, yeah.
And you're never going to get a 4 out of it. So it doesn't factor. So we're going to negative b plus or minus square root b squared minus 4 times a times c all over 2a. You guys with me so far? I know we're kind of jumping. Poor Michaela's been gone. Synthetic probably looks like what? So x equals 4 plus or minus, what's 16 minus 28?
Negative 12.
Big number, negative 12. Over 2. So x equals 4 plus or minus 2i radical 3 over 2.
2 plus minus I
What were my other answers? Thank you. How many answers are we supposed to have? Supposed to have 5. How many do we have? We have 5. Do you see now why, if it's double answer, why I do list it more than once? All right. Other than Michaela, who hasn't been here, how are the rest of us feeling? Those of us that have been here? Feeling okay? Let's take a look at this one. So what's the first thing you want to do with it? Factor it. No, not factor it. Graph it. Could you factor this? Real quick, time out. Don't write this down, but I want to show you something. Right away, you're like, 4 terms. We can factor 4 terms, right? Grouping. Don't write this down. So normally you'd be like, all right, 4 terms. I can factor this. So GCF here is x squared. So we'd have x squared minus 9. Here you would take out negative 4. So x minus 3. Common factor? I don't have one.
We're missing it, sorry.
So you can't. That's x plus 3, x minus 3. You could factor further. But the whole grouping idea, when you do that, you should have common factor right here. And I don't.
Yeah, so you could do that.
No, I can't. It does not. Because you have to circle it and tap, and then erases everything. That would be horrible. Like, ow! The whole thing's gone.
I'm sure there's a setting that you have.
That may be a setting, but. All right, so let's go ahead and graph this. Is it? Cool, I haven't graphed it yet. Let's look at it.
It looks fun.
It's not hard to type, though. That's good. Math is always fun. You watch your mouth.
That wasn't fun until I hit algebra.
It's fun, right?
I don't know. I used to be terrible at math. I've been doing
Ooh, that's a fun one. So let's confirm with the table. Which nice ones do we have? Negative 2, 1, and 3. Sorry, I worked from. You got to say it in order. Yes, I do. Take a look at your, guys, boys, take a look at your graph. Did it bounce off of negative 2? Yes. Yeah. Guys, did you hear what Jacob just said? Jacob, say that again.
Yeah, we got all right here. This is one.
Yeah!
So do I need to do any work? I'm done. I don't have to do any work.
I like the look of this one.
I don't have to. This could be fun. Like,
Yeah, guys, if I can find all the answers, what are you going to do? I could do synthetic to check them, make sure I get 0 for remainder, but why? Why?
Get 0.
Yeah, I'm moving on. All right. I found them all. How many should this one have for answers? 4. Let's type it in. Are we going to get, do we get lucky again?
probably not. Knowing you.
No
He's like,
That you know me so well. I'm going to miss you guys next semester. I have to train a new set of kids all over again.
train them like dogs.
Yeah. I've trained you guys. You know me. You know what I do. You know what I like. Like, you behave appropriately. Like, you're wonderful. You guys should go into pre-calc.
Next year I'm taking pre-calc.
I mean, it's hard. It's pre-calc. You'll be fine. You'll be
So,
fine.
yeah, my brother's doing that. Oh!
You hit clear, didn't you? Did you tap the board? All right. What do we notice on our answers?
Blank.
Blank. Do we have to? We have -2 and 1. All right. Are we doing okay so far? Everybody got -2 and 1. Okay, so we know we're missing 2 answers. Is it possible one of those answers showed up 3 times? Why not? Going straight through means it's either once or 3 or 5, whatever. Is it possible that one of those showed up 3 times? It's possible. And we know it's not twice because it didn't bounce off the number. At least once, it could be 3 times, but we don't know. All right. The easiest way to figure it out, let's do our synthetic and see where we're at. So 1, 1, 2, 4, -8. Use -2. So, really? I used -2. Did you use -2? And synthetic with the 1. All right. So we're left x² plus 0x plus 4. So do I really have an x term?
Difference of terms.
Yeah. What's the word difference mean? What's difference mean? Difference means subtract. Do you have a difference of squares? Hold on. The term is difference of squares. That's be like the x plus 2, x minus 2, right? Is that a difference of squares? It does not factor. It doesn't factor.
So it'd be
No.
plus minus
This doesn't factor.
plus minus 2i.
Yeah. So x² equals -4. So x equals plus or minus 2i. And then -2 and 1. So just be careful in that factoring. I know you're like, oh, x², 4, difference of squares. Yeah, it's not. There's no difference. So did it go through 3 times at any of those numbers?
No.
No, it didn't. The other 2 were imaginary. More often than not, it usually just shows up once or twice. Not very often does it actually show up 3 times. It's possible, just not very often. Questions here before we move on? Yes. Right, but like on the last one, I found all my answers. Sometimes if you find 3 of them that are nice, we can get it all the way down to like just an x, make it linear. Right. So it was possible that this answer showed up 3 times. It'd still be 4. If this one showed up 3 times and then this one, that'd make 4. It's possible, we're just not sure of it. It's okay if we can get it down to linear, that's fine too. What? Let's look at this one. All right, guys, graph it. Anthony, Jared, graph it. This one? I just switched to the next problem. You want to try again? What are the answers? Yeah, how come you don't know them right away if you already graphed it?
No, why do you keep doing that?
What are you doing? Hitting clear?
What? No, I'm just
No, you actually
my
just grabbed
steps.
it.
Carrot
You
forward.
grabbed it. It doesn't have any.
I'll go carrot forward, and I'll just keep going. And I'll forget that I have to go. Oh.
You forget. Hit y equals. X to 4, 4 is cubed. You have a minus or a negative instead of a minus. So it'll multiply it if you have that. Keep arrowing over until it highlights it. One more time, one more time. There you go, hit minus. There you go. Hit graph.
Yeah, guys.
All right. Is this one a little rough?
Yeah.
Looking at your graph, none of them are pretty. Now there are zeros, it obviously crosses, but the table doesn't show any. Is it possible that you can figure out maybe what a nice one is?
Is it the trace?
We can do that, but even easier, guys, just take a look at your graph. There's a kind of nice one in there. Yeah, it's close to -2 and 2, but those aren't pretty. What about the other one? It looks like -1/2. Is it possible that I could get a half off of this?
And it would be 2, right? Maybe 1/2, because it's
Right. So if -1/2 is an answer, it would show up twice, which would be fantastic, right? Looks like it. So, but honestly, what do we do to check it? What's the easiest, fastest way to check it? To me, it's faster to just guess at -1/2, do my synthetic, and see what I get. To me, that's faster, even than hitting the buttons on the calculator. Yeah, but you still have to do left bound, right bound, all that craziness. So it looks like -1/2. Looks like it. Oh, that was a terrible fix to my 2. All right, so let's try synthetic and see what we get. Is -1/2 really where it's at? Yeah, it is. If you don't like the guess, could you hit second, trace, and left bound, right bound? Don't want to guess, hit that button. It got a little complicated, you're right, it did. So was it faster just to do the synthetic? For me, it is. You might disagree. You might prefer to hit the buttons on the calculator. For me, it's faster just to try it and see if it works. Yeah, since it bounced off -1/2, let's do it again. Because right now we're down to a cubic. I want it down to quadratic. It worked twice. Beautiful. Now I know the other 2 answers are almost 2 and almost -2, right? They're close. So can I solve this now? Yeah. We started x to the 4th, synthetic twice, we're down to x squared plus 0x minus 12. So really there's 4x squared minus 12. I can pull out a GCF, or I can be extra lazy and just do what? I can just move the 12 to the other side. I don't have a b term. So 4x squared equals 12. So x squared equals 3. So x equals plus or minus radical 3.
What is radical?
1 point something ish.
I don't know. Wait, what's he looking at? Calculating.
Oh yeah, I could have been done with that a long time ago. Can you give me an ugly decimal for an answer?
I mean, we could.
Will I give you credit? No.
How are we supposed to convert ugly decimal by doing this?
This, if you write this as decimal, you can't convert it
That's what I mean.
because it's irrational. You can't. Yeah, you can't. Now, on the calculator, that trace feature would have helped you find the negative half to confirm that it was negative half. But you never get this off the calculator unless you know what radical 3 is as a decimal. I don't. I know it's 1 point something ish, you know.
Could you do, if you trace the other two instead of
The radical 3s. No, because if I trace these, it's going to give me that 1.7 blah 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 blah. Yeah, it's giving you radical 3 as a decimal, which we don't know what that is.
Okay.
Yeah, Jesse. Not that I'm aware of. I'm not going to say no because maybe, I don't know, but nothing that I've ever seen before, no. All right, how are we feeling?